I did not get a chance to look at it yet. Okay, but I will update things. Okay, so how does a simple random sample work? That's something we will address within the dot plot stuff that we'll look at in a little bit. If you fill out all the notes, do you have to do the prayer chart thing?
Teachers and students, excuse this all call, but I need Cassandra Bilbro for checkout.
Bilbo?
Yes,
Bilbo
sir.
Baggins?
I think it's because they can't check who's in what. Right?
Correct, because the internet's out. So yes, you have to do the Frere model thing. The reason why I want you to still do the Frere model thing is that Frere model, right, your notes is 9 pages front and back, I think, something like that. The Frere model is 1 page front and back. And that Frere model will be your study guide for the AP exam. Yes, Sprig.
Am I supposed to fill out all this? All this?
So here's the thing. The more detail that you put in there, the better off you'll be. I'm going to let y'all do one round of this on your own. I'm going to show you what Ashton did last year and then what a couple other people did just so you see some examples. But here's the thing. I would fill it out as completely as possible because, again, that's your study guide for the AP exam that you're building from the beginning. Okay? And if you write, and so I'll say this, you only have to do one side of that because the experiments aren't on the quiz tomorrow, the demonstrated understanding. It's just the observational study stuff and surveys. So use that as part of your study guide. As you look through your notes, as you look through the textbook, fill that out and that should help you study for the quizzes and for the test. Does that make sense?
So do we have to fill out the Frere model for like the quiz tomorrow or like the unit test?
So I want you to submit your Frere model before each quiz. So submit the corresponding set of notes. Because what I did was last year I waited until the test and then I didn't get a chance to look at the notes. And so like I don't just collect your notes, I give you feedback if there's something big that I notice you're missing to help you study, things like that. So the only thing you have to do before tomorrow is observational studies and surveys. You do not have to do the experiment side.
Okay.
Does that make sense?
Yes.
And don't just write down pure definitions, write down why it's important, examples if you need to, stuff like that. I said just that you can add more stuff in. All right, talking about simple random sample. Today, what would happen if you sampled the data with replacement? So realistically, sampling data with replacement is usually not what you want. However, sometimes it's not really feasible to do it without replacement. However, there's something known as the 10% rule or 10% condition. If you're sampling less than 10% of the population, it's almost like we can treat our observations as independent. So you can do it with replacement in that case, so it doesn't really change much. I'll try to find an example of when you could or would want replacement, but for the most part, we don't want replacement. Yeah. So Nate, do stratified random samples begin with dividing into groups, randomly selecting groups, and then randomly selecting within? No. So okay, so you're combining this right here, Nate, with you're combining some of the cluster and stratified ideas. In stratified, and we're going to talk more about this today, with stratified, you divide into groups, and then you randomly select some within each group. In cluster, you put into groups, and then you randomly select the entire group. So cluster, you're selecting the entire group. Stratified, you're selecting some within each group. And we'll talk about when that's most efficient, when it's not. We'll look at that homework number 2 in a second. And I have no clue who or what Frere is. I just know I've been using Frere models as graphic organizers for years. They seem to be helpful. Okay, so homework number 2, what page is that?
It was page 265.
Where's mine? Okay. Say that one more time. What page?
265.
265?
What's this?
And what number?
17 and 15.
17 and 15?
Yeah. And sneeze. We get tissue for our hands.
Okay, number 15, the owner of a large restaurant is considering a new no tipping policy and wants to survey a sample of employees. The policy would add 20% to the cost of food and beverages, and additional revenue would be distributed equally among servers and kitchen staff. Describe how to select a stratified random sample of approximately 30 employees. Okay, so what strata should we probably consider in the context of that problem?
Their job.
Okay, so their job. So what would that be then?
Kitchen staff and servers.
So I would split my groups into kitchen staff and servers because they might differ on how they feel about that tipping policy, right? And then what would we do?
Randomly select 15 from each group.
So randomly select 15 from each group. But how are you going to randomly select?
Random number generator.
So we got to be clear. Remember, when we talk about this and we explain how we're doing it, we've got to label, we've got to randomly generate, and we've got to select, right? So you got to include that language. So yeah, I would split it into servers and kitchen staff. And now we'll make this, let's say this really, ooh, that's not the marker I want to use, that one. Let's say we have 30 servers and 15 kitchen staff. I don't know if that's realistic. Never worked in a kitchen before. But in this case, would I want, now let's double that since we have so many, 60 and 30. In this case, would I want to go 15 and 15?
No.
What would I want?
Like 10 and 20.
20. Yeah.
So yeah, I need a total of 30, right? I need 30. So I would probably do how many of the servers?
20.
20. And how many of the kitchen staff?
10.
1/3 each.
Yeah. So I would do it proportional to how many people there are in each group.
So do I have to say that?
No, but if they do give that kind of detail, you would want to account for that, right?
Okay.
Yeah, so just keep that in mind. But split them into groups based on servers and kitchen staff on the AP exam. You would want to clarify it is because servers and kitchen staff may feel differently about that tipping policy. Label each server from 1 to 60, label each kitchen staff member from 1 to 30, randomly generate 20 numbers from 1 to 60, randomly generate 10 numbers 1 to 30, select the people associated with those numbers. Or you could do 1 to 60 and 31 to 90. That's another option.
Alright.
So, something like that. Does that answer your question completely? Does that bring up any other questions for people? No, we good there? Sorry, go for it.
So you have to do it proportional to...
I would always do it proportional. Yeah. I would always do it proportional. I don't know, I'll investigate to see if the AP exam has really clarified or required that ever before, but I would always do it proportional because here's the thing. If you have more servers, then they should have in my opinion, should have a bigger vote on which way that the policy goes, right? Like, who's it going to affect more, servers or kitchen staff? Servers. They should get a bigger voice in that case, which was the whole argument when the U.S. Constitution was written for large states versus small states. That's why we got a House and the Senate. So, anyways, huh?
This is not if you go.
But isn't it? A corporation employs 2,000 male and 500 female engineers. Stratified random sample of 250 gives every individual in the population the same chance to be chosen for the sample. Is it an SRS? Ooh, excellent question. And so here's the thing. I was going to bring this up already in the notes, so I'm glad this comes up here from this question. So what is an SRS? Simple random sample. But what has to be true for a simple random sample?
It's truly random.
Every
It's
individual
all,
has an equal
it counts
chance
everything.
of getting chosen.
So if you go in and look, say again, Michael?
It's not equal.
What do you mean?
It's like the percentage doesn't, I don't know how to describe it.
Okay.
I just have a thought of it.
Every
Keep going.
individual should have an equal chance of being chosen in the sample.
So by that logic, would this be an SRS?
No,
Why does every person not have an equal chance?
because
Because it's,
I feel like there would be more male engineers selected if it was a
You'd have to
jury
have
and
the whole
sample.
population.
Well, what percent of our male is selected?
10%.
10%. What percent of our females are selected?
10%.
That's too, like,
So, I mean, like-
perfect.
They have an equal chance.
yeah, but you've separated it into different clusters.
Right. And so I will say this. It's a stratified, it's not a simple random sample, but here's a bigger issue, and I need to be clear on this. In this case, every person has an equal chance of being selected. But that's not what a simple random sample says. A simple random sample says, is such that each group of n objects, in this case people, is equally likely to be selected. And this took me a couple years to
This
wrap
party is
my
all called
mind
ID.
around the difference. But
Shemaiah,
here's the thing,
McGee, and
If
Shemaiah. McGee,
every
check out,
group is equally likely to be selected in a simple random sample, it's possible that I could get a group of entirely what?
Men.
All men, right? Is that possible in this case?
No.
No. It's possible that I get all 250 engineers being female, if it's a true simple random sample. So it's important to understand, it's not that they each have an equally likely chance of being selected, because that's what I understood it for way too long. It's that every group of n objects is equally likely to be selected. So if you can't have all 250 people selected be male, then that's not a simple random sample. I can't get every possible group. It's because I have to have 200 males and 50 females. What's your question? I will say this, in a random selection period, not a simple random sample, in a random selection period, every person is equally likely to be selected. If it's random selection, every person has an equally likely chance of being selected, unless it's not proportional, right? If we did 125, 125.
I have one more question.
Okay, go for it.
Homework 9. Homework 1, question 9. It's like, I don't know how would you answer this question?
Okay. Did you look, by the way, at the answers from the book?
Where's the answers?
There's a whole separate PDF where I have answers uploaded as well.
Whoops.
It's okay. So, I mean, these are good conversations. The idea, though, is that you can go check your answers, and if it still doesn't make sense, come and ask. But these are still good conversations. You're on the staff of a member of Congress who is considering a bill and receipt on the issue of which. Oh, okay. So, what does anyone see the problem with this study design to see how people feel about the legislation?
like a voluntary response, voluntary.
It's not non-response, it's voluntary response. So it's tough to tell sometimes the difference between voluntary response and response, or non-response. But in this case, remember, non-response is I reached out and they didn't respond. Okay? Here, people just volunteered,
I
right?
thought they sent out the letters.
Oh, did they?
No, they didn't.
Yeah, I was like, I didn't think I saw anything about them sending out letters. And so, what is one explanation that the majority of these people oppose the legislation?
People who support it aren't gonna go and be like, I support this.
Right. Who emails and protests the people who are angry and feel really strongly the opposite way, right? Usually if you're in support of something, you don't feel the need to write in this way. Right? So this is a biased sample due to voluntary response. We good with that?
Yeah.
That jive with what we've learned? Okay. Sweet. And by the way, I did set it up in AP Classroom so that you could see feedback on your responses to the progress check, correct?
Yeah.
Does that sound right? Okay.
Yeah.
Alright, so really quickly, I made this note to myself so I didn't forget. Here's the reality. When we are doing studies, right, there's always going to be sampling variability, right? But if our sample does not represent the population, first off, we'd say it is unrepresentative or not representative. If our sample does not represent the population, that's a problem, right? But does that data point represent the population? I mean, the actual average was about 3.5, right? That data point right there is, I don't know, 4.6, 4.8 or so. So does that represent the population average number of letters per word?
No.
No. Does this data point represent the average number of letters per word?
No.
No. But the reality is, it's not about one data point being unrepresentative, right? Bias does not mean a data point is unrepresentative. Also, we said that this one up here was a subjective sample. That was biased, but did we have some data points really, really close to what it was supposed to be? Right? So remember that unrepresentative does not automatically mean biased. Biased means that it is the sampling will produce samples that are consistently unrepresentative. That doesn't mean it misses the mark once. It means that overall it misses the mark a lot. I need y'all to remember that difference. I want to make sure that that is clear based on some of the notes I was seeing. Biased means it's a bad sampling method. Biased means it is a bad sampling method. And so lots of responses or lots of samples would be unrepresentative. It would be, multiple samples would be unrepresentative. Okay? Ms. Kowalski, can you put these up over there? One side is already sticky, and then that for the other side to get it to stay up. On that board. Yeah, we'll put it on that board for now. We'll just put it on that board. All right, so I changed my lesson plans a little bit. I went and found a new lesson that is very strong to help us tackle some of these things. So you already have some stuff to put notes on, but I'm going to give you another sheet today. And that's the other thing, reason why I want you to do the Frere models is because I want you to summarize your notes into a succinct group. It'll help, I promise. Okay, so we just addressed simple random sample. Every group of n objects is equally likely to be selected, right? We did all that. Did all that. I don't know why I didn't delete all that. Talked about all that. All right. So here's what we're about to do. So I know a lot of us were like, but Mr. Kinney, I want to do the dot plot. Hey guys, to do dot plots, you know what you have to have?
Dots.
You have to have. Well, yeah, but what if it's dots? How many? How much data do you need?
A lot.
A lot, or at least more than one, and each of you only had one data point. I could have had you do multiple samples, but I figured that'd be silly. Instead, I took the data that I had from y'all, which I only got 6 good points. And you'll notice that Miss Kowalski is putting these up now. So let's do, now that we're done with that up there. And let me, that one, that, and that.
Oh, no, those.
Okay, you take that. We'll put them both over here. All right, here, we'll split it over here. All right, so this way, a little bit further down. Okay, so this is the data that y'all collected, right? We see a simple random sample. Did anyone, by the way, figure out what the average yield would have been for all, what was it, 20 plots of land?
Wasn't it like around 70?
Not just around, that was really smooth.
I know exactly.
It was exactly 70. I'm sure Jaden went in and actually did all the calculations.
No, it just said it on the plot.
Yeah, it just
Oh,
says-
did it?
says
Okay.
average
My bad.
yield on the
Okay, so it
page.
was actually 70, okay?
Yes, it says it on.
And so I want y'all to look at this really quickly. Looking here, we have our simple random sample. We have our systematic random sample, which I don't know why I didn't just go by tens. But this, essentially, notice, is 70 right here. And so 70 here, 70 here. And each of these random sampling approaches, what does it look like the average is? Or like the center of our data?
70.
70, right? So I want to point out Like, the fact of the matter is, if we're randomly selecting and there's no other forms of bias, we're still going to have the right center, aren't we? Random sampling, let me make this clear. Random sampling yields accurate results. Okay? Random sampling is going to yield accurate results. That's true for every single one of these. Even that cluster by column down there. Those are accurate results. What do I mean by accurate?
Like it shows the general, like.
They're all centered around.
They are centered around the bullseye. They are centered around the mean, right? If was there an example in the videos, am I remembering right, with a target and they talked about accuracy versus precision? Okay? Random sampling is going to yield accurate results. Period. Every single one of these is centered around the true mean. Does that mean that that random sampling method is the best in that case, though? No, right? So what's the issue here, and here, and here?
Why is that dot like all the way to the bottom?
Mistakes happened. That's not supposed to be there. Ignore it. Okay.
Is it like a negative?
We should just use whiteout. I'm not, one, I don't carry whiteout. Two, I wasn't gonna waste it. So what's the issue with the simple random sample and the stratified by row and cluster by column? Variability. It's super what?
Spaced out.
Spaced out. Okay. The statistical term. No, don't restart my computer. I will fight you. Sorry, my computer was telling me things. Yeah, it's super spaced out. The statistical term there is it's spread out. There's a lot of variability. And we'll talk more about measures of spread later. So stuff like the IQR, interquartile range, standard deviation, things like that. But yeah, the stratified by row, the simple random sample, cluster by column, they're accurate, but they're not super precise. Right? What we want is we want precise and accurate results. And so here's what I want us to think about, because this stratified by row, this cluster by column for sure, not precise. So why were these not precise, but that stratified by column and that cluster by row were very precise?
Because, like the rows had a pattern, like the first, column, my bad, the column 1 had like 4 through 10, or 4 through 6, or whatever.
Mm-hmm.
And then column 2 had 29 to, well, 27 to 32,
Mm-hmm.
etc.
Okay. By the way, why do you think the yields are so much better over here? Huh?
It's like in Minecraft, there's the river.
The river, right? If you've got water, that's going to be good for what?
Minecraft.
Not for Minecraft, for growth, for plants, right? So, yeah, when we look at this, I know. So when we look at this, right, like this has way better results. So when I look at my columns right here, what's an H word that you've definitely heard in your science classes that could describe, man, how did you know that? That's wild.
There's
What?
homogeneous.
Columns are homogeneous.
There's fur.
Okay.
From a water source.
Okay? Each of those columns, it doesn't mean they're exactly the same, but each of those columns, aren't they pretty similar?
Yep.
Pretty similar, okay? The rows are then heterogeneous, okay?
Oh, yeah.
The rows are heterogeneous. Those rows are mixed. And so I want you to think about it. When do you want to stratify and when do you want to use cluster? Do you want to stratify when the groups are homogeneous? Or do you want to use cluster when the groups are homogeneous?
Stratified.
Stratified? So when I look at stratified by row, that's fine, but not okay. But when I look at stratified by column over there, was that super precise?
Yeah.
Yeah. So when your groups are homogeneous, stratify. Right? So that goes back, stratified random sampling. That goes back to that question you had earlier, Nate, right? About stratified random sampling. If you have homogeneous groups, randomly select within those homogeneous groups. So we selected one from here, one from here, one from here, one from here. But if the groups are heterogeneous, if each group on its own looks like the population, what are you gonna use?
Cluster.
Yeah. If the groups are heterogeneous, if the groups are mixed so they look like the population, you're gonna use cluster sampling. That's what's happening with cluster and stratification. And in cluster, remember how you circled the entire group and you sampled that entire group? That's cluster sampling, when you take that entire group. Now, you could just take one group, or sometimes you could take entire groups. And, not to get crazy with it, but you can actually mix and match. For example, if we want to later find out if people know about survival bias, right? Then we could stratify by grades during advisory, and then cluster sample by taking entire advisory classes and asking them. So you can mix and match them, but there needs to be randomization, and we need to keep that in mind, right? So maybe we think that there's a difference in the way that students in each grade understand survivor bias, right? Maybe we think that upperclassmen understand survivor bias better than lowerclassmen do. So we go by grade. We do strata, keep them homogeneous in that regard. But we think it might be similar within each grade, and we don't really think that the groups matter, so maybe we randomly sample 2 or 3 entire groups. Okay? So let me end with this. Stratification, especially when you have homogeneous groups, it increases what? Decrease, you can say decrease or increase. What did we decrease when we... Variability, right? So we decrease spread or increase precision. Stratification, when you have a homogeneous group like this, increases precision / decreases spread. Does that make sense? I'm going to talk about cluster a little bit later. In general, simple random sample is all they're really going to super assess you on the AP exam, except on multiple choice. They will make sure that you can identify the different types. They're not going to ask you, hey, should you use stratified in this case, or should you use simple random sample? They might ask you, hey, what would be the grouping you would use for stratified random sampling? But they're not going to ask you to make a decision about stratified versus simple random. At least historically, that has not been the case. But I could always be proven wrong, and I'll continue to learn and grow. What are your questions up to this point? Makes sense, hopefully. Going once, going twice. Okay. Okay, so stratified random sampling. Have we adequately addressed what that is versus simple random? So remember, simple random, every group of n objects is equally likely to be selected. Stratified, we are looking at homogeneous groups. Oh, I should also make this note. With stratified, remember, we're going to create homogeneous groups. But how do we sample within those homogeneous groups?
Select one from each.
Yeah, but how do we select?
Random generator.
Randomly.
So we label, randomly generate, and select. But I would also point out within the strata, so remember the homogeneous groups are called my strata. Within the strata, we use a simple random sample. So like when you use stratified random sampling, within your strata, you're going to use a simple random sample. Or collect a simple random sample. Okay. Questions? Oh yeah. What's the benefit of using a stratified random sample?
Precision.
it increases the precision and it decreases that spread, right? So it increases precision, decreases that spread. And how do you choose a variable to stratify by?
Look if
The-
it's homogeneous.
Decrease the spread and make sure the
Characteristics.
So the grouping is similar in what respect?
Valid.
Is similar within due to, or yeah. I would probably need to reword this, but I'll think about that in a second. Respect to characteristic of interest. So what I would point out, going back to survivor bias, just because this has been a thing we discussed, we'll talk about some more. With survivor bias, could I create strata of guys versus girls? Brain, you're immediately like, eh. But here's the thing. If I put, or even split it in more groups, but if I do all males in one group and all females in another group, are those homogeneous groups?
Yeah.
I mean,
Yeah.
but like, it's not an interest, it's not a characteristic of interest. Like,
Right.
What is?
And that's my point is,
Yeah.
like, I don't think male versus female, there's going to be a difference in respect to survivor bias, right? I don't think that male versus female will have any differences. Now, freshmen knowing about survivor bias versus seniors knowing about survivor bias, I think that there might be a difference there. Okay? So the group needs to be, and I should say, similar within in respect to the characteristic of interest, but different between groups.
I was gonna say, you
I
need to
don't
reduce
know
overlap.
this.
Say again, Jaden?
You need to reduce overlap.
Reduce overlap? Yes. So yeah, you need to have differences between the groups, right? So those groups need to be different in respect to the characteristic of interest. Okay? So similar within in respect to the characteristic of interest, different between. Similar within, different between. That's a good stratum. Yes?
By the
Mike.
way, it's about the quiz tomorrow.
Say again?
It's about the quiz tomorrow.
Go for it.
Is it like mainly MCQ or
Multiple choice.
multiple choice? Okay.
Here's the thing I will say. Historically, and I need to go back in and see if I want to edit it, things like that, because I've been working on something else so I haven't actually finalized this quiz for tomorrow yet. Historically, I've done some true and false, some matching, some multiple choice. I will not give you an AP free response style question yet because we haven't practiced any.
Got you. I just asked because I want to know what I want to write to ChatGPT to make context.
Smart.
That's what I did for bio.
I will also say that, and please do notice that is perfectly acceptable. That's not cheating. Don't use ChatGPT to write papers for me, but that's a good. No, I'm encouraging. Like that's a good way to create an assignment. It will be similar to. What I would do is I would study the concepts in the textbook, know them well. I would definitely look again at the progress checks. I would look at the assigned problems and think along those lines. Yes?
Is it gonna be similar to what the project, oh my gosh,
Progress check?
yes.
There will definitely be questions similar. Yes?
Okay.
Yes?
Is there anything specific you want to study? You want to just look overall?
So if you remember, I sent y'all a highlighted proficiency scale with that identifies the exact topics that will be directly addressed. So I emailed that proficiency scale to you that highlighted the exact terms and concepts that will be on the AP, on the demonstrating understanding tomorrow.
Thank you.
Yep. But basically, it's everything with observational studies and surveys.
How strict are you on like answers?
What do you mean?
Wait, because it's just like A or B, it's not,
If it's multiple choice, on free response though.
yeah, that's, I guess.
So yeah, if it's multiple choice, I mean, it's right or wrong.
Yeah.
And I don't love those kinds of questions. I don't use questions like that in my regular classes, but On an AP class, I have to because that's what the AP exam will be like. But on the free response, I always use the same model that the AP exam uses, which is E, P, and I. Essentially correct, partially correct, incorrect. And so you have to remember, like, especially with the way we've been talking about these things and discussing these things, in statistics is, do you ever prove anything? Is anything ever 100% guaranteed?
No.
So like you have to have the essential idea correct. There are things you have to talk about, but there's no like perfect language or writing for it. You can change the order of the writing, things like that. All right, but again, we'll get plenty of chances to look at these things. The progress check or the proficiency scales are a good chunk of your grade. So like the demonstrate understanding is your first assessment on each concept, not a huge part of your grade. Yes?
Are we filling this in after or before the test?
Neither. So the proficiency scale is for you to do a self-assessment. I have a digital version of each of these that I'm going to email to you and to your parents so that you can see what I have seen and what I have marked off. That way, not only do you have the self-assessment, but you also have my assessment so that you know what to still work on.
I'm confused. What do you mean by that?
What do you mean?
Like,
A digital copy?
so is, huh?
I have a copy of this in Google Drive
Uh-huh.
that I can go in and check off when I see certain concepts. And I'm going to share it with you and your parents so that y'all can view what I have marked off.
Okay.
Does that answer your question? Cool. All right, there's homework number 2. Let's see. We talked about cluster versus stratified, pros and cons. Okay, so what do you think a pro? We've talked about the difference between these two, right? So it's cluster when the groups are what? Heterogeneous. Okay. One thing I will also make a note of is you don't just want them heterogeneous, you want them to be heterogeneous,
And representative.
and a yes representative and a small, let's say it this way, snapshot. So I'm going to put that word representative as well. Small snapshot of the population. What I mean by that is, so representative, if we had clusters, but each cluster didn't look like the population, that wouldn't be helpful, right? When I go back, whoops, and I look here, does this one row look similar to what the population looks like?
Yeah.
Right? We got some low, we got some mid, we got some high. That's a small snapshot. That one cluster represents the population well. So cluster, that one group, that one small snapshot of the population represents the population well. And so that's what we want with cluster. Usually, do you think clusters are super nail on the head, head on the nail? Head on the nail representative of the population like that?
No.
No. Hitting the nail on the head, that's the phrase I'm looking for, and I butchered it, it's fine. No, they're usually not, but what is a pro? So that would be a con, right? A con of cluster sampling, not, so clusters are not super representative. Of the population. However, what would be a pro of a cluster sample?
Saves time.
Saves time, right? Like, instead of looking at all the freshmen and doing a simple random sample of labeling all the freshmen, randomly generating 20 names, and going and selecting them, I could just go do one entire advisory class. Or 2 entire advisory classes. So what's the pro of cluster?
Stage resources.
Super, ooh, that's a good way to say it. I was gonna say super easy, but I like that. Saves resources. What's the biggest resource it saves?
Money.
Time.
Oh.
And money, sure. But time is money, isn't it?
Oh my gosh. Wow.
Okay, so it saves time, like that's one of the big ones, but it saves resources in general, but it saves time. Okay? Is this helping finalize a lot of those ideas that we've been looking at and thinking about? Okay, questions before we focus on bias for a hot second? No, have we ever done all the types of bias?
What's your bias?
Lots of them.
There's
No, that's.
Is it K-pop?
Say again.
Yes.
What's
What's your bias?
We've already talked about the different types of bias in this class, haven't we? No, there's more in the notes about bias, isn't there?
I remember there was one on a.
Or have we already done
There was
that?
one on the progress check called
Okay.
like under.
Under coverage?
Yeah, which I mean that was, I guess it's kind of self-explanatory. It's not, you're not covering it.
Sometimes, so I will say this, under coverage is also sometimes called selection bias, but all that we mean when we say under coverage, and it's in the book, is that not everyone has an equally likely chance of being selected. For instance, let's say, and I think they even have this example in the books, let's say I'm trying to figure out how people plan on voting for the next presidential election in 4 years, because yes, I'm already looking forward to that, but 4 years down the line, and the way that they're figuring out, or they're doing the polling, is by calling house phones. What's the issue with calling house phones to see how people are going to be voting?
I don't think
Younger
we're not
people
gonna
don't really have house phones.
Oh yeah, I would say that's the really big one. Not only do most people not everyone has a house phone. In general, younger generations don't do house phones, period. I don't even think my parents still have one, but like,
Or they don't.
yeah, or, okay.
We got rid of them, like my family.
Right.
We got rid of ours.
So in general, so like who are we gonna hear from if we're only doing house phones? Older generation, right? Can you even remotely get in touch with homeless people in that way? No, right? You can't get in touch with younger generations. And even today, like I don't know how they're working around it, but someone mentioned like it's tough to call now because I know I screen my calls, right? Like if I don't know the number, I don't pick it up. Sometimes I might use the Google screening service and like say, hey, what's going on, or what do you want, or what do you need, or whatever, without actually picking up the phone. But like people don't pick up the phone.
Yeah, it's just like my phone, like it doesn't even ring it. It's just.
Yeah. If it's a pollster, it's not always as common, but yeah, if it's someone, a solicitor or something like that, they're pretty much.
Scam likely.
Yeah, exactly.
Like someone has to like either call me or text me beforehand because
Right.
they just won't even ring me.
Gotcha. So that's under coverage though. Like, is there a part of the population that is not likely to be selected even with random sampling? Yeah, if it's a younger generation, I'm probably not getting in touch with them if I'm trying to do a house phone, right? And that's where like polling and surveys are in a rough spot right now because of the way that we interact with pollsters and just like how people can get in touch these days. All right, all that to say, I'm going to move through this part quickly. Let me know if you have any questions with this. But what 3 parts do you need for every single one of these questions? Or these parts here?
A label,
Label.
randomly.
You need a label,
Generate.
randomly generate, and select. Like you had to talk about those 3 things with every piece here. So how to select a simple random sample of 500 books, label every book 1 to 20,000, right? Randomly generate what?
For B.
Numbers.
How many numbers?
500. 500 numbers?
You are correct, but there's something you're missing that the AP, there we go. You gotta randomly generate 500 unique numbers, right? So it is without replacement, and then
Select those randomly generated numbers.
select the books, so be careful, not select the numbers, select the books corresponding to those numbers, right? Label your books 1 to 20,000, randomly generate 500 unique numbers, select those books, okay? So how would you do a stratified random sample? So again, we want groups that are similar within, but the groups might be different. What are some groups kind of identified up here where it might be similar for the page numbers within that group, but different between the groups? Genres, right? Fiction versus biography versus whatever else, right? So strata would be the type of book, right? And so we would and I will say you couldn't do everything within this, but label each stratum 1 to whatever, randomly generate however many books. Yeah, I need to add more details the more I'm looking at this for this one. But randomly generate a simple random sample from with each stratum. We can answer this one, I think, yeah. So part C, for a cluster sample, what are going to be our clusters?
Shelves.
The shelves, right? They're mixed shelves. Which I don't know what librarian would have mixed shelves, that's goofy. But mixed shelves of 50 books each, so what is that? 400 shelves?
Yeah.
Is that right?
Yes.
It's a lot of shelves. Okay, so 400 shelves. So we would label our shelves 1 to 400. Then what would I do?
Wait, for the AP exam, do you have to specify 1 to 400?
I would.
Yes.
In a case like this, when you know, hey, there's 50 books each shelf, and there's 20,000 books, we know there's going to be 400 shelves, right? 20,000 divided by 50. So I would label my shelves 1 to 400. Can't do that with a stratified random sample because we don't know, right? Randomly generate how many numbers?
400.
Nope.
No, 100 unique numbers for.
Nope.
Already 10.
Well, how many books are in each shelf?
I sure did think that 100 times.
So we have 50 books each shelf. We need 500 books. So how many shelves do we need? 10, right? Randomly generate 10 unique numbers. Remember, you always randomly generate numbers. And then you select every book on those shelves. We good? So now, are you with me?
Yeah.
You sure? Okay, so remember, label, generate, or randomly generate, select. And so you got to include those 3 pieces. Please make sure you do that. I don't want to get to the test and have someone not identify label, generate, and select, or randomly generate and select.
I just didn't know that 10 times 50 was
That's
50.
I know, small things. Okay, so this I think was pretty straightforward for everybody. Make sure though you don't just put pure definitions, right? Context with it, examples. Just listen, guys. The more you flesh out that information, the better you're going to be off. Okay. And so we talked about the undercovers, the non-response, all that stuff. The trying to remember if there's anything I remember specifically. I don't, off the top of my head. What I would say is the book has the definition in a box. Read the extra information around it. I know it's a hassle. I promise you though, it'll help you in the long run. Okay.
This is a math class.
Literally, I don't want to read.
How dare we read to get information? I just wanted to automatically seep into my brain. Okay. What problems might non-response cause? Let's make sure we address this. Yeah, it's always it has something with bias, but going back to that case with the pollsters, not pollsters, the congresswoman who had people writing in about how they felt about some new law. And I know that was voluntary response. We'll talk about that more in a second. But why non-response would be the same thing? Like if I sent out letters asking you to tell me how you feel about these things, and let's say 50% of the people I sent letters to don't respond, how could that affect my results?
No variability?
Say again?
No variability?
Not just no variability, think about it, 50% of the people responded. What about the other 50%? Do I know about them?
No.
It's a bias.
So they didn't care as much, right?
Yeah.
Who's responding in that case?
People who feel strongly.
The people who feel strongly. And who usually feel strongly? The people protesting, right?
Bias.
I don't know about the other 50%. Going back to the planes, right? From the problem that Mr. Young's shaver had on the AP classroom stuff, there was the issue, it's not non-response because they got shot down, But what did all the planes have in common that didn't make it back?
Shots on the tail.
Yeah, they had like.
Not tail.
Yes.
Body.
It was tail.
It was shots
Shots
on
on
the
the
The ones
body.
who didn't respond, like, come back had shots on the tail. That's why they sank. Yes, I swear to goodness.
It's like,
Yeah. It was.
It was-
Half
Fuel
shots?
was. What was your question?
It was on the tail. I will
It was
fight
on
you
the
over this.
video.
It was on the
Wait,
little
what-
things
Ms.
on the
Kowalski,
tail.
which planes got shot down?
The ones that got shot on the nose.
She didn't even watch the AP classroom.
It was on the tail.
Well-
on the video, it was on the tail.
Oh,
On
yeah,
my
in
mom.
the video, it's on,
On my
the tail.
soul.
On
That
my
one,
soul.
on the nose.
On every.
On
I mean,
your
that's kinda like
picture,
the
it's the nose. On the
Wait,
everyone's I
Sister.
checked between the two.
It's almost like.
Oh, well then, they messed up
She's
that
dead.
AP video, my bad. So if you go and look though, there's actually pictures with shots on the tail. But it was the ones who got shot in the nose that didn't actually make it back. Regardless though, so you're right, my bad. So,
Well,
huh?
wasn't it also the fuselage? Because like if they shoot it, okay.
Oh, yeah.
I mean,
In real life, in real life.
But I mean, like,
But like.
Yes, but the vast majority, the fact of the matter, let's put it this way. Non-response, we didn't have any planes that got shot in the nose.
Or the tail.
There were some that got shot in the tail. There were not any that got shot in the nose. So that group though was different than the rest. That's the bigger thing. That's what I want you to hear. If there's a reason why they don't respond, and that group is different than the group who did respond, well then I'm up a creek. I don't have good information, right? So why is non-response a problem? We don't have data from them, from, let's say, that group. And it could be very different from the data we collected. Like, non-response is a major issue if the group we don't get data from is different from the group we do get data from. Non-response is a major issue if the group we don't get data from is different from the group we do get data from. The planes that didn't make it back, or there were no planes that made it back that got shot in the nose. There were other ones that went down as well. Fuselage, tail, whatever you want to say. But listen, if the nose gets shot up and your pilot dies, you're toast, okay? So yeah, how is the group different? So that's the question you have to ask. And so I will say this, if we have non-response, does that guarantee the other group is different?
No.
No, but we always have to be wary of when we have non-response. How is the group different that we didn't get data from, okay? So how is it different from voluntary response?
Voluntary response, you have self-selection bias.
Self-selection, right? So voluntary response, you choose to participate in the study or not. Non-response, you were chosen, but you don't respond. So voluntary response, you choose to participate. Non-response, you were chosen, you just don't respond. I need you to hear that clearly, because that's a small detail that it took me a while to master, but it's important. Non-response, you were selected, you just chose not to respond. Voluntary, you chose to engage in the study. Okay? How can we reduce non-response?
Make them have to respond.
You can't really make somebody
Yeah.
respond, but let's say the congresswoman wants to know how her constituents feels. She emails letters out, she only gets 30% of responses. What can she do?
Follow-up or incentive?
Can she send them another message, another letter?
She
Will
can,
that get more data?
Yeah.
bribe.
Free money. Make it
Free money? What are you gonna say?
$9.
Free?
Yeah,
You can like send a thing like yes or no.
Make it simpler, right?
Yes.
Guys, I can go ahead and tell you this. I don't get great responses from parents, like high response rate from parents when I try to do parent contact. So you know what I have to do? Reach back out, right? Like that's how it works. I know, I get it. And so like follow-up is important, okay? Response bias. What can response bias, or what is response bias?
Occurs when there is a systematic pattern of inaccurate answers to a survey question.
Okay, so what does that actually mean? What could that look like?
It can cause false statistics to be spread.
Yeah, but like, what could cause, so like that's the result, right?
Poorly worded.
That's always the result, but like what could cause
People
it?
lying about
Poorly worded,
themselves,
people
like
don't
if you're
know.
gonna ask
Poorly
someone like
worded.
how much do
wording.
you weigh?
If they don't
or
have it.
something,
Okay,
just
Yeah,
like-
so-
poorly worded questions.
Poorly worded questions, okay, so we're gonna come back to this in a second. Poorly worded questions that have ambiguity, that cause confusion, can affect people's responses, right? If I directly ask survey students what their weight is,
Too bad.
They're gonna say
is
lead.
that, could that affect people's responses?
I'm 100 pounds,
Okay,
you
so
guys.
how, so here's a question.
I'm like 2 pounds.
How could I, listen, how could I reduce that response bias?
You
Make it anonymous.
Could I pass out a sheet of paper that has an anonymous response to it, so I don't know directly who it is?
Yeah.
Could that reduce the response bias?
you
Yes.
can you
I've heard
can
my pencil.
make things like with less answers to select, so people aren't as like confused like with the yes no thing.
And there's sometimes when that's what you want, okay? Not always, but sometimes. Okay, sound good? How you feeling? Make sense? It's not you awake now?
Like it won't
Yeah.
press, it won't
I
press
love
lead.
it, but I'm gonna.
Got you. Okay, really quickly, I want to just talk about inference here. So when we say inference, what do we actually mean?
Make predictions?
Make predictions about what?
The entire
The
population.
population.
Okay, and so I want to point this out. There's two major types of inferences we like to make. Two, okay?
Generalization.
So we want to make a generalization about a
Population.
population.
Do you think so?
So generalization about a population. And that, what do we need to be able to make a good generalization about a population?
A good sample of the
We need a
population?
good sample, that is, there's an R word for that,
Representative.
representative. We need randomization, but if our sample's not representative, I don't have a good prediction, do I? So like, when you got to choose the words, you chose those big words, not representative of the population, not a good estimate. When we did random sampling, not super precise, but was it accurate? Was it centered around the true average word length? Yes. So that is a generalization about a population. We need representative samples. What do we need in order, what do we have to reduce in order to get a representative sample?
Variability, bias.
So we reduce bias. Remember, bias is the idea of missing the mark, not the spread. The idea of bias is missing the mark. We need representative samples, so we reduce bias. Does anyone know the other inference we like to make?
How do you know what the market is? Like,
You never do.
exactly, because like if there's bias, then like,
Correct.
how do you find it?
Well, so that's where we have to study the principles of good study design and do everything in our power to reduce the effects of bias. So you're right. In a true study, the idea is that we don't know the entire population. We can't do a census. So we don't know if there's bias or not, but we know good principles for study design. We know, okay, we gotta make sure that we reduce undercoverage as much as possible. We gotta make sure that we are attempting to reduce response bias. We've gotta make sure that we're doing random sampling, right? And so that reduces the effective bias. That's why I said we can never eliminate it, but we can reduce the effects of it. Okay? Sound good? Does anyone remember or know the other inference we like to make?
Well, like how they'll act in the future?
No.
What's the start
Can we
with?
get a hint?
C
C
and
and
E.
E.
Cause and effect?
Cause and effect.
What's
So
it
how
called?
will it act in the future?
That's called a prospective study. That's not cause and effect.
So that's what I meant.
Okay. Cause and effect, let me clarify, is a different type of study.
Isn't that longitudinal?
Well, longitudinal is when you follow, you go long term and follow the data. Yeah. So like you keep track of 300 twins for 40 years or something, or 5 years or something like that. Okay. Sampling variability. Every sample is going to be what? Different, right? Different samples will have different results. Sampling variability is always there. But what is the benefit of increasing sample size?
There's more user population.
So, I have 3 people talking, sorry. Let's start with Peter. Peter, what were you saying?
Like it becomes closer to like the population.
So, when you have a higher sample size, is it likely that you're ever going to get an average yield of 0 or 25 even?
Maybe. I mean, yeah, no. Percent.
Okay, let's go back over here. Come on. Okay, listen. I know that Jaden was being funny and did like 8.2 letters per word over here, right? But if we had selected 50 words, I don't even think there's 50 words with 8 letters in them on that song, right? So if you increase the sample size, it's going to help make sure, as long as you've reduced bias, that your value is closer to the what?
Accurate.
So to the true mean, or the population mean, or the population median. It's called the parameter, okay? We're going to talk more about parameters moving forward. I think I mentioned that word last week, but the idea is increasing the sample size, make sure that our values are closer to the true or population value. Increasing the sample size helps the sample be closer to the population. Don't really sweat margin of error much. We'll talk about that later. So bigger sample sizes, make sure the sample values or the statistics are closer to the parameter. Okay? And again, don't forget, all that's in the textbook.
Yay.
And it's page 266, not 226.
Whatever.
All right, so here's where we are now. Ms. Kowalski, can you find the 4.3, not 4.1, the 4.31, and pass that out to everybody? So here's what we're going to do with the last, oh man, I've been meant to get here a long time ago, but with the time we have left, an observational study, that's all we talked about. Observational studies, surveys, that's been it. So an observational study, quite literally what? Observes individuals and measures variables of interest, but does not attempt to influence the responses. A survey is a type of observational study, okay? And so the whole idea, is it not back there?
It's on the right too. Oh,
Right here, found it. It's okay, well, I was just trying to hide it from you.
this is 4.1.
That's 4.1, 4.3 right there.
Sorry, you said just the 4.3 thing.
Yeah,
and
yeah.
it wasn't-
That one, sorry, my bad.
Sure.
The skew the script one. Alright, so this skew the script is actually from Mr. Young Shaver. I'm going to start mixing some of his stuff in with what I've been doing.
No.
Yep, okay, so, yep, no bad statistics, right? No BS. So, here's the thing. What does it mean for two variables to have an association?
They have a relationship.
They have a relationship, right? So, for example, I'm going to share with you something that I talked about with my Algebra 2 class today. Did you know that high schooler students or teen mental illness issues, suicide rates, self-harm shot up in 2010?
2010.
2010.
I thought it would be 2020.
I mean, there might have been issues there too. But 2010 is where they noticed the largest spike.
It's the
Oh,
dang
what?
internet these days.
Well,
This is
What
a
came
science
do you know what
program.
came out in the summer of 2007?
Facebook?
Instagram.
No, Facebook.
Please confirm.
4chan.
Starts with a lowercase I.
Okay.
Instagram.
I've been saying it the whole time.
What'd you say?
iPhone.
iPhones came out in 2007.
See, it works out right because we introduced suicide rates.
So here's the thing, right? Like, guys, iPhones have been around since 2007. They started getting in hands of students right around 2007, but really it started to take off in 2010, 2011. And we see a huge spike in mental disorders and struggles with mental health. I should say it that way, mental health. Issues with mental
It
health.
was the birth of Jimmy.
So let me ask you this. Did iPhones cause mental health issues?
Maybe.
Yes.
It could have attributed to it, but you
They have a
can't really
correlation.
make
Not
such a
So they have
Correlation.
an association, which you will often hear called a
Correlation.
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 Is there a huge correlation there?
Yeah.
Yeah. Should we address that and think about that?
Yeah.
Yes. My wife and I have decided we're not giving our son a smartphone until he gets into high school.
Oh, that's smart.
He might get a phone before that, but not a smartphone. And it will be for when he goes to hang out with friends, so he can contact us, things like that. But like the reality is like high school students, middle school students, even elementary school students are exposed to horrific things that they are not ready for and should not be seeing. You and I both know that this is the case, right? So here's the thing. Is the iPhone causing it? No, but is there a huge correlation? Is there an association? Yes, okay? So, if there is an association between variables, should we conclude there's a cause and effect? Yes,
Is
Brayden.
that where the saying correlation is not not directly causation comes from? Because I think he had wellness class, and whenever I'd say something, he'd always say that to me.
Correlation.
annoying.
Yeah, correlation is not causation.
Correlation is not.
It's true though, right? So here's the thing. Are they related? 1,000%. Is it cause and effect though?
No.
No, right? What do you have to have in order to establish cause and effect?
Data.
Yeah, over time.
Data over time does not show causation. Proof. What does that proof need to look like?
Direct correlation.
It's like the linear.
Here's the thing. Hold on. I just want to point this out.
Well, things
With the
go up.
iPhones, with smartphones, over time, we have seen as humans that mental health crises have increased the longer the smartphone's been out. That doesn't establish causation. I won't ever be able to establish causation because in order to establish causation, you have to have an
Experiment.
experiment.
What the-
Only experiments can establish causation.
I don't know.
Page one.
So, when we say experiment, what do we mean?
2 pages.
Repeated trials, testing a hypothesis.
Okay?
Oh, no,
You
no,
went to ed?
Drumming.
No, I didn't.
Uh,
Girl, I was just saying crap from AP Bio.
I will say, replication is what you're talking about when you say repeated trials. That's important. We'll talk about that later. But researchers are going to apply something. There's a word that you might see later in the notes that might be helpful here. It might also be on the proficiency scale.
Unit and subject, treatment,
Operation.
factor, level. Hold on.
They apply something. What do you think they're applying?
Control group, placebo, single-blind
Slow down and actually think about it. Where they apply.
I'm not listening.
replication,
Teeth? Okay, is this just
Wait,
head
teeth?
now?
Analyze.
test, treatment,
Oh.
They apply treatment.
trial.
Okay? So guys, researchers apply treatments. Now you said an E word earlier. Is something type of variable?
Oh, explanatory.
Explanatory variable. Your treatments are different combinations, right? So your explanatory variables are also called factors.
No.
Different factors, or factors have levels. So factors can have levels. I'll give examples of this in a second. And your combination, or combinations of levels and factors are called treatments. Okay? So explanatory variables are also called Factors, right? Factors play into something. Explanatory variables. Your explanatory variables, your factors can have, well, they can get into treatments, but they can have what? Levels. And your combination of your levels and your factors are called treatments. So for example, let me ask you this. So I just want to give a very simple biology case. I don't know biology super well, but I think everyone understands this. What can affect the growth of a plant?
Water.
Okay.
Photosynthesis.
So,
Actually, light reaction and.
Oh my gosh, it's
so the growth of a
And the
plant.
Calvin cycle.
So the growth of the plant is the response. Give me one factor that can affect the growth of a plant.
CO2.
Okay, so
Nutrients.
let's say so CO2 concentration. That's one factor. Concentration. What else?
Soil.
Soil.
Waddle.
Fertilizer. Soil pH.
And we'll take fertilizer under soil. And let's say what were you saying?
Waddle.
Water. Okay. So those are my factors: CO2 concentration, soil, and water. Right?
What about sun?
I mean, sun can affect it. I just asked for a couple of factors,
Light
right?
reaction.
So,
Yeah.
carbon dioxide concentration, right? I don't know realistic carbon dioxide concentrations
Come on, Michael.
for plant growth. You got anything, Michael?
Okay, he didn't teach us this.
Okay, I'm just gonna make something up. 10%, 20%, I feel like that's really high. Okay? The 10%, 20%, 30% carbon dioxide concentration, that's gonna be considered my levels. Okay? And to make my life easy, I'm just gonna focus on water. Let's say that we give the plant 10 milliliters of water a day,
That might be what Apes is doing.
20 milliliters of water per day,
Oh, yeah, that is what we're doing.
and 30 milliliters of water per day. So there's another set of levels, right?
You guys saw
Now I
that
can
difference?
combine, hear me, I can combine the 10% CO2 concentration with 10 milliliters, 10% with 20, 10% with 30, 20% with 10, 20% with 20, etc. Each of those combinations would be called a treatment. The treatment, let me put this last detail in there. The treatments are the conditions applied to the experimental units. What do you think I mean by experimental units?
Changing units.
Not changing units, it's not a variable. What would be the experimental units that I'm applying these treatments to?
Plant seed.
Plants, or plant seed, right? The experimental units are what the treatments are applied
So it's a
to.
control. No, not control group.
Subjects.
Wait. The responding variable.
Well, but the response variable would actually just be the growth, right? But a good way to think about it is the subjects. Your experimental units are subjects, but in statistics, we only use the term subjects for people. So we would not call the plants subjects. In statistics, we only call what type of experimental unit subjects?
People.
People. In statistics, only people are called subjects. Everything else is an experimental unit.
Why?
That's sad.
Why? Because someone decided one day.
I'm
And it
so
may
sorry.
even be that you do use the word subject elsewhere, but in the AP statistics world, subject only means the people.
I'm gonna crash out.
Okay? Oh, whatever. Okay. So here's the thing though, and we're going to talk about some of these things more when we get into the papers that Ms. Kowalski passed out. Are there things that affect plant growth besides carbon dioxide concentration
Yes.
and water?
Yes.
So what's another variable that could play in?
Light.
Soil pH,
Proximity to other plants.
okay? So proximity to other plants,
Bugs.
bugs,
Pesticides.
sunlight, pesticides. Hey, what if those variables
Temperature.
affect my growth and it's not one of these? Do you know what I'm going to call that if it's one of those other variables I don't care about? Confounding.
What the crap?
This word confounding
Where
is when
this?
this is the idea of a variable prevents so variable that is not explanatory, or is not, let's say, the explanatory of interest. Prevents an accurate understanding of cause and effect. I'm gonna rewrite some things in a second.
I'll erase the board. This is a fat mess.
Does that help?
A little bit.
Okay, so confounding is when you have a variable that is not the explanatory of interest. It could explain the response, but it's not the explanatory of interest, and so it prevents an accurate understanding of cause and effect. Okay? So, what is confounding is an experiment. It prevents cause and effect, or an accurate understanding of cause and effect. What is confounding like from observational studies?
Unaccounted for variable?
Yeah, but we don't have unaccounted for variables. What was the goal in observational studies again?
To reduce interference.
No, what was the goal of an observational study? I think you said it, but hold on to it. What's the goal of an observational study? To make an
Observation.
one an observation, to make an inference about what?
The whole
The population.
About the whole population, right? But what can prevent us from making an accurate inference about the whole population?
Bias.
Not having
Confounding.
Bias.
Bias.
We're just using all the words.
Vocab.
Guys, vocabulary matters, like statistics, vocabulary matters a lot. Listen, confounding prevents an accurate understanding of cause and effect. Just like bias prevented an accurate understanding of the population. Remember, bias makes our sampling unrepresentative or non-representative of the population. Confounding goes with experiments and cause and effect. Bias goes with observational studies and inferences about the population.
You were gonna show us the chart thingies that like Ashton and other people did.
Yeah,
Or
I'll show it to you tomorrow. Listen, don't.
I thought the test was tomorrow.
Well, the quiz is tomorrow.
What?
Not
What's
the test.
going on?
Huh?
They do
It's
before
gonna
the
snow
quiz?
tomorrow.
No, it's not.
Yes.
Listen.
How do you know?
Hey, listen, Sprig.
What's it like?
Don't stress at a time. I can email it to you if you would
Is
like.
it not due before the quiz?
It is. I'm gonna be very nice on the grading. Hey, Sprig.
Ugh.
Listen. Legitimately, if you legitimately try, you will get a fine grade on submitting your FAIR model, okay? I'm going to show you so that you can compare against what he did and what others did afterwards. But as long as you legitimately try it, and don't just Google it like half of my class did last time, you'll be fine, okay? Because what the whole thing is, I want to give you personalized feedback so that you can update it before the test. Okay?
Oh, before the test?
Yes.
So is it like do the night?
No.
Tomorrow.
I'm gonna give you personalized feedback before the, and then
Oh,
you're
the
gonna
test
read
tomorrow.
the test. Not the demonstrated
I
understanding.
understand that
On the
now.
test. We're there. All right. Big yikes. Okay, so experimental design. This is what Mr. Young-Shaver developed that we're going to be using mixed in with our lesson. So wherever we just stopped in the notes that I already had, I want you to put in some of the Young-Shaver stuff, but we'll get there. We'll see in a second. Okay, so this is actually a topic that I really, really like, and so I wanted to talk about this one. I think it's important. So, gender gaps in STEM. So when we look at percent of all science paper authors, 35% are female, 65% are male. More data collection needs to be done related to scientists who don't identify by this binary. Correct, that is accurate as well. That's why it says gender gaps with an asterisk. But my question for you in looking at this is, why is there a gap there? Why is there such a difference? Roughly, what percent of America or the world identifies as female and identifies as male?
It's around
51 to
50-50.
49.
It's roughly 50-50, 49-49. But does that look like this right here?
No.
So what can explain that drastic difference here?
I don't know.
Women
Girls
not
usually become like.
Wait, when is this,
teachers,
2005?
Check the
Twenty-
bro.
I can't read it.
Oh, that was, the paper authors was 2005. This report came from 2020.
Like
My mom was
Study?
part of that percentage.
Gender discrimination.
Okay.
I mean, it's probably way different now.
Actually.
Maybe, but not really.
I
Really
thought
good?
So, look here, so percent of engineering paper authors, only
Well,
18%
18%
are
are
like
female,
bio.
82% male, physics, 15 to 85, mathematics, 15 to 85. So, the question then becomes, there we go. And then percent of data science. So, the data science world is newer, but again, very male dominated. So, what is the true cause of the gender gaps in science? What are some of the explanations? So we're about to look at observational studies versus experiments. Correlation does not equal causation. So what causes this trend? What are possible causes?
Hiring discrimination.
I know, I went one too far, right? So one possible cause is hiring discrimination. What's another one, Jaden?
There's a lot of sexism in academia outside of the United States.
Okay, so sexism is even within the United States, not just outside, but yes, so hiring discrimination, sexism within the world of academia, any other?
Wait, is this within the US or outside? Like,
Yeah,
in
like
and
what is
outside?
this?
Oh, that's a great question, I don't know.
I mean,
It's the same, to be
It's the
honest.
Boston Consulting Group, so it's probably US.
Probably the
people
US,
usually
but-
like follow the path of their parents like a lot of the time.
Okay, so people usually follow the path of their parents.
So it'll be
Here's
like-
a question,
and then-
does that mean that girls typically follow the path of their mothers and sons follow the path of their fathers? So what
And
you're
then,
saying
like-
is there's like a socialization component to it?
And keep in mind that like women are kind of new to the workforce.
Mm-hmm.
And like back in World War II, that's like when we were introduced to it. Like predominantly industrialization and STEM has been a male-dominated field for like ever. So like this is probably the highest percentage it's been like super.
Yeah, women getting into science and technology, engineering, math is a fairly recent thing. So is it hiring discrimination or is it just we're catching up? Is it a socialization thing? That's the question, right? We know for sure, and so there's these two things. So women are given fewer research and workforce opportunities in STEM due to either discriminatory practices in research industry hiring, or fewer women can enter and succeed in the field. So, or that could be the cause of it, right? So can we prove this cause? Well, one group of people decided to try and find out.
Like put in like job applications for female names, etc.
Interesting, let's look. So from this observed data alone, we cannot prove discrimination, right? This just gives us a what? Another C word. This data gives us a
Correlation.
correlation and association. There's definitely a correlation there. We don't know causation yet because what have we not done?
Experiment.
Experiment, okay. So here's, and I'll upload these slides, especially with Young Shaver stuff if you want it, but this, I believe, is in his, yeah, so if you look on Young Shaver stuff, should have remembered confounding variables there, he defines it really well, but notice it gives the one possible cause of gender gaps is hiring bias, the proving the idea of cause, but confounding variables what? Provide a what?
Alternative.
Alternative explanation for trends between explanatory and response. And so I do like that definition. That's saying the same thing that I said earlier, but it's a good way to say it. It provides an alternative explanation. It prevents an accurate understanding of cause and effect, which I just realized it is about time to go. So there's our potential confounding socialization. Tomorrow, we'll pick up from there. Oh yeah, we tend to foster boys' belief in talent in STEM. And so more men pursue STEM, or we see what our parents do, right? And so we're going to look at those causes for the trends tomorrow. Are experiments going to be on your demonstrate understanding tomorrow?
Yeah.
Maybe.
No.
Experiments are not on there. It is only about Observational studies and surveys.
What if I do both anyway?
Hey, go ahead and study it, knock it out, but I'm just saying, I'm not putting experiments on your, demonstrate understanding.
Or both.
That's a shit.